All right, let's talk about 7.2, number 21. So, um, where? Okay, so here it is. Okay, so Jordan asks for 7.2, number 21. He says, I use the tabular method to solve the problem, but I'm unsure how to integrate cosine x over x. And just based on this part, I'm a little afraid that you may have misunderstood the problem. Not that it's an easy problem to solve anyway, but notice that this is not sine of x times ln of x. This is sine of ln of x. So when you do the when you do the tabular method, let's say, there's really only one function here. It's sine of ln of x. It's a composition of functions, but that doesn't really help you with the tabular method. So unless you know how to integrate that, you have no choice but to differentiate it, right? So you have to put sine ln of x here, and then here you just have dx, right? So when we differentiate this, we're going to get cosine of ln of x, cosine of ln of x, times the derivative of ln of x, which is 1 over x, right? So that's what we're going to get. And then here, when we integrate dx, we just get x. So notice now, what you're going to end up integrating is not cosine of x divided by x. It's going to be actually cosine of ln of x divided by x times x. And so this x and that x will cancel. And so you'll just be integrating cosine of ln of x. Now, that's different than what you had here, right? Cosine of x over x. This is not what you're going to integrate. What you're going to integrate is cosine of ln of x, right? And that's what's a little bit challenging because we still don't. I mean, so it's a different thing, but it's still not any easier to integrate, right? So how do you integrate cosine of ln of x? Well, so we could continue on with the tabular method. We could go to the next step and integrate the next thing. I have a feeling that we're going to get something nasty, right? So if I differentiate this again, I don't get to cross off the x's if I'm going to keep going, right? Like, so I can integrate this easily, x squared over 2. But if I differentiate this again, I'm going to get, goodness, it's going to be derivative of the bottom, or sorry, the bottom times the derivative of the top, which is going to be negative sine of ln of x times 1 over x, which I guess we'll just cancel that. So I'm just going to cancel that off and just call it negative sine ln of x. So that's, and then minus the top times the derivative of the bottom. Well, the derivative of the bottom is just 1, so it's just minus the top cosine of ln of x, divided by the bottom squared, x squared. So you can see, if I integrate this last line now, the x squareds will cancel, which is nice. But then I'll have a negative sine ln of x minus cosine of ln of x that I have to integrate. And so I have a problem, right? It's looking like it's getting worse. So here's what I think I'm going to do. I'm not going to do this next line. Instead, I'm going to say, all right, so this original integral is going to be x. It's going to be x sine of ln of x minus the integral of, the x's will cancel, and it's just going to be the integral of cosine of ln of x dx. And now what I'm going to do is I'm just going to do integration by parts again, but from scratch, right? From scratch. So I'm going to focus on this integral and do integration by parts again. So again, I'm kind of forced to have a cosine of ln of x here. And then if I differentiate, it's going to be a negative sine of ln of x times 1 over x. And this is going to be x. So now the same deal, right? If I keep differentiating, I'm going to end up with something nasty in the next step. And so I don't really want to do that. I think I'm just going to stop there, and I'm going to call this x cosine of ln of x minus negative sine of ln of x, right? The integral of sine of ln of x. Okay. So bringing this equality down, right, I've got x sine of ln of x minus x cosine of ln of x, and then minus a negative, so that'll be a positive, right? So I'm doing plus, minus. This minus and that minus cancel and give me a positive. The x's will cancel, and I've got the integral of sine of ln of x dx. Now, what is this equal to? Well, this is equal to the integral of sine of ln of x dx. So I'm going to take this one step further and go ahead and distribute that negative sign. So I've got integral of sine ln of x dx equals x sine ln of x minus x cosine of ln of x minus the integral of sine of ln of x dx. Now, notice that this integral matches that integral. So what you can do is add this integral over to the other side and then solve for it, right? So if I add integral of sine ln of x dx over to the other side, I'm going to get 2 times the integral of sine of ln of x dx equals x sine of ln of x minus x cosine of ln of x. And if I divide by 2, then I'm going to get integral of sine of ln of x dx equals, I can factor out, so I'm going to divide by 2, but I can also factor out an x. So I'm going to take out an x over 2 times sine of ln of x minus cosine of ln of x. And then I guess I have to have my constant of integration, right? But there's the answer to the integral, right? There's integral of sine of ln of x. So this is one of those ones where it's like you have to recognize that, at some point when you're doing this integration by parts, at some point you end up with an integral that matches the integral that you started with, and so then you can kind of solve for that integral. So I actually love problems like this because it's almost like you're done before you expect to be done, but and you're able to solve for it kind of algebraically in a way. But that's that one. So if you thought of a different way to do it, that's fine. But that's how it occurred to me to do that one. And admittedly, that was definitely kind of a tricky problem. 7.2, number 21. So that's that one.